Hello, ladies and gentlemen. Thank you very much for watching. In January 2013, the Puget Sound Professional Chapter of Engineers Without Borders sent a team of engineers down to a remote region in central Nicaragua. The team addressed aspects of a very important issue that has been and currently is affecting the health, lives, and futures of many communities in the highlands of this amazing country. The sad fact is, that morning mocha many of you may have enjoyed could have caused a lot of pollution in a river somewhere in the beautiful coffee-growing regions of the world. This will make more sense in a few minutes. I would like to introduce our partners on the ground, Agros International. Agros International is a group committed to breaking the cycle of poverty for rural families in Central America by enabling landless communities to achieve land ownership and economic stability. Agros has learned that the root causes of poverty extend across communities and are passed down from generation to generation. And so the Agros development model is holistic, sustainable, and focused on long-term results. Agros paved the way for our visit to the village of Tierra Nueva, which is home to some 150 families. I need to give a huge thank you to Universidad Centroamericana in Managua. Most people say that of all the schools in Nicaragua, UCA produces the highest caliber of graduate. They certainly have high-caliber students, as the team found out. We were fortunate enough to travel with 2 engineering students who were an incredible value add to the trip. The team has also been able to utilize the university's labs in Managua to analyze soil and water samples taken on site. This is incredibly important, as it is extremely difficult to transport water or soil samples across international borders. And a huge thanks to the College of Science and Engineering at Seattle University, who loaned the team surveying gear and water testing equipment. Seattle U has invited the team, as well as students from Nicaragua, to participate in upcoming laboratory experiments at Seattle University. These experiments will be specifically designed to model coffee wastewater processing. This will greatly aid the team's design process. I'm going to spend a few minutes telling you about this site visit trip, but first I want to mention a few things about coffee. No, not in its finished form. Not the product many of you enjoy every morning. Not mochas or Americanos or lattes. I'm talking about the coffee plant itself. That finicky and fragile being which grows the coffee cherries and the seeds within that are eventually roasted into your favorite early day beverage. The coffee plant is indeed finicky. For example, this plant will only tolerate the most luxurious of environments. It chooses to grow in tropical climates and latitudes, and at about 1,000 to 1,300 meters in elevation. This foliage definitely prefers the good life, including feeding on nutrient-rich soils found in the scenic views of volcanic regions. It is a picky plant. It likes some wet, some dry, some sun, some shade, etc. This plant is also fragile. It is very susceptible to disease, fungus, and bugs. It is very hard to grow and very hard to keep healthy. So why are we talking about this hard to grow, hard to keep healthy, finicky plant, coffee? We're talking about coffee because if a farmer is lucky enough to live in the regions where coffee is willing to grow, then that farmer will want a relationship with coffee. There have been wide swings in the price of coffee worldwide in recent years. Despite this, coffee remains a crop of choice for farmers where it can be grown. Over frijoles, beans, over maracuya, passion fruit, and even over cacao for making chocolate. Coffee is the delicate, picky plant that farmers often want to grow on their land. But there is a problem. A big problem that occurs when coffee is processed on small, rural Nicaraguan coffee farms. This is where the Engineers Without Borders team comes in. This is how many people who are able to grow coffee get that coffee to market. This represents the lowest level of technology of coffee process. Coffee cherries are carried in large quantities called quintales. 1 quintale weighs approximately 100 pounds and comes in a sack exactly like the one you see on this young man's shoulders. I imagine this young person, even soaking wet, probably doesn't outweigh that bag by more than maybe 30 pounds. Many people have to carry these bags huge distances and over rough terrain until they get to a place where the coffee processing can begin. That 100-pound quintale must be carried until it reaches a place like this. This is a place where can be found the coffee cherry depulping device. These depulpers are usually owned by a collective of people, as they are expensive. The cost is about $3,000 US, and they are produced primarily in Brazil. You can see the piles of waste that are produced. The seeds, or coffee beans, are then put back into those bags to ferment and afterwards sun-dried. The coffee is then taken further down the valley, lower in elevation, and higher in temperature, where the coffee is further dried to about 12% water content. At this point, the coffee is suitable for international shipping. This basic depulping process and dry fermentation represents the lowest level of sophistication of coffee process. Therefore, it yields a poor quality of coffee, not exportable, for example, and commands the lowest prices locally. Here we see how a farmer can obtain a much higher quality end result of a coffee harvest. This is a wet mill beneficio. This is the kind of system that the families of the village of Tierra Nueva want to see on their land. This includes the depulping process you just saw, but now the fermentation phase takes place in water tanks for about 12 to 18 hours, and then the coffee is rinsed like you see here. But here is the problem. This is why the team from Engineers Without Borders is here. It's not a sexy problem, but it is a very important one. The coffee beans have a sticky mucilage that must be removed before the coffee can be transported or sold. It's hard to see in the video, but the coffee rinse water being generated is highly murky and pollutant. Very few, if any, small coffee farmers are knowledgeable in how to deal with the cloudy wastewater you see here. It is called by the locals agua miel, which means honey water or sweet water. Often this water goes into nearby rivers in huge volumes, and then into downstream drinking water systems. This region produces some of the highest quality coffee in the world, and it also produces world-class industrial-level coffee waste. So what is in that cloudy rinse water that we don't want to see reach the streams? Here you go, all you chemists and wastewater engineers in the audience. Here is a very basic breakdown of that murky, cloudy coffee rinse water. It is important to note that this data is relative to a coffee plant grown its whole life without pesticides or fertilizers applied, which is very rare. This data represents the waste from farms that still may qualify to sell their coffee as organic or shade-grown or free trade, etc. When we compare coffee waste to, say, raw sewage, and also to something like dairy processing, we see that coffee processing produces results that require greater treatment. Coffee processing waste has a high level of nitrogen and phosphorus, a high level of BOD, low pH, high TSS, and although it's not as bad as sugar processing, there is no doubt that this is a high-level industrial-grade wastewater and a potential problem. So there was the challenge. There were many volunteers with Engineers Without Borders who held a lot of meetings, did a lot of paperwork, and figured out a lot of things. We got our equipment and our act together, and got the team on a flight, and sent down to Managua, Nicaragua. So who is on this team? First, our fearless leader is Set. She is a hydraulic engineer with West Consultants over in Bellevue. Dan is a propulsion engineer with Boeing and the past president of the Puget Sound Chapter of Engineers Without Borders. Max, who has a wastewater engineering background and is currently a traffic engineer with Pertit up in Everett. And I am Patrick, and I am with Appia Engineering Consultants. I have a civil, environmental, and sound engineering background. And of course, our student team members from UCA, Adriana and Nora. This is a photo of them doing work in one of our many makeshift labs we created at places where we were staying in the evenings. These two engineering students added a lot of value to the team and certainly raised the tone of the entire endeavor. Upon arrival at the airport in Managua, things went really well. Right after clearing customs and such, we got some cash and bought SIM cards for our phones. Right outside the terminal, we met up with our friend Carlos, who runs the chemistry department at UCA. He introduced us to one of the students who would be joining us. It was great to touch base with him. We also met Kira, who is the country director for Agros. She gave us a great welcome and provided us with very good logistical, contact, and schedule information. She was responsible for setting up much of our logistics, including a translator that we would meet later on. She was wonderful. Then we got the shuttle to the rental car place and got the heck out of Managua. We drove the big 4x4 we had rented for about an hour and a half. We stopped and parked in front of this guy and his horse in a place called La Dalia, about 45 minutes north of Matagalpa. Although this man and his horse certainly looked like they could have taught us a few things, we didn't stop for them. They just happened to be across the street from here. This was our first meeting spot, the Agros office in La Dalia. Within this office, we found a very talented and dedicated group of people. There were engineers, office directors, a few agronomists, and some agronomic technicos, as they are called. We had a really good conversation with all of them. We felt it was really important to understand where they were at in terms of the many progressive projects they are handling. These include making a road in some really rough terrain, making new houses, and a just-finished 14-kilometer-long hand-dug potable water pipeline, to name a few. It was important to discuss with them the details of the feasibility of a wet mill coffee process beneficio. We needed to understand how to make a plan to design something that was in a good balance and in a good schedule with all of the agendas, requirements, and priorities at the table. We learned a lot this day. And here we arrive in Tierra Nueva, home to 150 families. This place is big and beautiful. Very big and very beautiful. You can't see it here, but we are standing next to a water tank, and Carlos, one of the civil engineers, is pointing out the source of the water. It's an ojo de agua, which means spring source. It's 14 kilometers away and 200 meters above where we are standing. This is very near that ojo de agua, 14 kilometers away and 200 meters above where we were standing. We felt it was really important to understand all the hydrology and hydraulics of the area before we could begin our design or choose a good location, so we did a lot of hiking around. Everywhere we hiked, we saw beautiful lands like this. A lot of care and planning had gone into every bit of this area. Here you can see carefully planted young beans making their way up and out of the ground. Then we came to the site where they had hoped to put a wet mill coffee process. It was a centrally located area, and there will be a road constructed where we are standing in the mud. The site has water access and is a good distance from the nearest stream. So we sat down and got to work. We took soil and water samples and did infiltration testing. We also performed an extensive field survey of the area to create a topo map. The team traveled to our next assignment on this trip to do some follow-up on some previously completed projects in another village. Luckily, we had time to stop at the National Coffee Museum in Matagalpa, which was on the way. We were able to learn things like how the volatility of coffee prices internationally has affected the economy of this region. This area has a very deep relationship with coffee historically, we found out. And a few blocks away, we were lucky enough to run into the president of Secosamac, which is one of the coffee cooperatives centered in Matagalpa. The purpose of the cooperatives is to commoditize the coffee. They buy it from farmers and act as a broker between growers, processors, buyers, and exporters. Here he is showing us a roasting device that he has next to a coffee lab and tasting room on site. Buyers come from all over the world to sample test batches from here. Later we arrived at another Agros community, El Eden, which was the site of a previously completed rainwater catchment and cistern and Ram River pump system. Engineers Without Borders had last visited there in 2010. We had a great meeting and conversation with the community. Dan was there in 2010 working on the installation of these projects, and it was a great reunion for all. We spent a good deal of time with them and learned of where the village was in terms of its projects, its agriculture, and what they felt were good steps toward their collective future. This is Roberto. He was given a rocket stove in 2010, and he was asked how it had been working. He said it was very handy indeed. He found it very useful for times when he had to go out and sleep in the fields in order to prevent thieves from stealing his crops. He loved the fact that he could pretty much burn any biomass out in the field and have a quick, hot meal as a result. Here is an example of what the village has done on its land wherever it can get water. These are some very sexy peppers one farmer is producing. He is using plastic for weed guard and efficient drip irrigation systems for his crops. He seems to understand water management and agronomy very well. Dan spent a lot of time getting feedback on the rainwater catchment system and its use. It was reported to be functioning as expected and is offsetting a lot of water demand by providing for irrigation, water for livestock, and toilet flushing from the cistern in the dry season. The village seemed really happy with it. Here was introduced an unknown on the trip. A ram-style pump was placed here with a water wheel to pump water uphill for irrigation. It was reported that the pump failed to provide the head needed to be useful at times when the river was very low. The pump was moved to a different village that had less of a pumping requirement. We are still doing more research to understand exactly why this pump failed, and we will pursue that portion of the project until its conclusion. Our last stop was just past Matagalpa and take a right turn at the tank you see here. This is La Selva Negra, probably the most biodiverse farm in all of Central America. Here they have a very advanced system for coffee process, including a biodigester which produces methane gas for kitchen cooking and water heating. It was great to tour their facility and learn about what kinds of technology we can hopefully scale down for use on smaller farms. Then we headed to Managua and subsequently our flight out and back to sweet home Seattle. So now what? Now we measure twice and cut once. That's what. We do a lot of literature research, we do a lot of math, and we carefully quantify all of our assumptions. We keep in very good contact and communication with our friends at Agros. We make 2 or 3 design alternatives for the site. These will probably include a sedimentation basin, followed by a sand filter. Downstream of that, probably a constructed wetland, which is basically a horizontal anaerobic flow-through rock media. We plan to return to oversee a completed construction by the beginning of coffee harvest season 2014. If anyone has any questions, please feel free to contact me. Thanks for watching, and I hope you have a really great day.
He venido desde lejos cargando en mi corazón una alforja llena de versos amarrada con bejucos de mi propia inspiración. Hoy por ser tu aniversario te le entrego hecha canción pa' que todos te cantemos con el alma y corazón. Felicidades mi Matagalpa, mi linda perla del septentrión, indita pura de todo el norte, la consentida de la región. Vos sos la reina del alma mía, mi dulce sueño, mi compañía, el gran orgullo que nunca olvido, bendita tierra donde nací. Felicidades mi Matagalpa, con esta canción vengo a entregarte mi corazón. Bajo el cielo de tus montañas se visten las flores con el rocío, salta el venado con alegría para decirte felicidades, canta el jilguero cerca del río, viene bajando sobre una estrella la patroncita Virgen Mercedes para decirte felicidades y con nosotros poder cantarte. Felicidades mi Matagalpa, mi linda perla del septentrión, minita pura de todo el norte, la consentida de la región. Vos sos la reina del alma mía, mi dulce sueño, mi compañía, el gran orgullo que nunca olvido, bendita tierra donde nací. Felicidades mi Matagalpa, mi linda perla del septentrión, indita pura de todo el norte, la consentida de la región. Vos sos la reina del alma mía, mi dulce sueño, mi compañía, el gran orgullo que nunca olvido, bendita tierra donde nací, bendita tierra donde nací.